Okay, thank you. I'm Angelo-Massafra from the University of Bologna in Italy, and today I'm pleased to be here with you to present the evolution of my PhD research within the BTwin project. That is a project that I'm coordinating at my university about the topic of digital twins for performance management of existing buildings, or better, the digital decision support system supporting performance management. I'll be fast. I will just introduce the title of contents of this presentation. So I'll give an introduction about the background of the research, then present method and tools, finally ended with a very simple demonstration of the toolkit we are going to develop within this project, and finally present some next steps that I'll publish and show you in the future, I hope. So starting from the background, as you can imagine from the title of presentation, the focus is the management phase of existing buildings that, as you know, is a particularly critical phase because most of economic but also environmental impacts occur during this period, with extent of these impacts that vary according to the performance of the buildings but also their management practices. Therefore, on the one hand, there is a strong need today, as also discussed in previous presentation, about managing and controlling performance of buildings during their use. But on the other time, this is a very complex problem because on the one hand involves different management layers. So think, for example, technical, but also strategical, but also administrative management. And the other hand, building managers that usually or sometimes are not technicians need to control or just understand performance of buildings in terms, for example, of occupancy management, but also energy efficiency, cost optimization, sustainability, and so on. We have very many topics. So fortunately, as we know, and as we discussed in this day, we have numerous technologies that can support management of performance of existing buildings. For example, I can mention building information modeling, but also BPS that stand here for building performance simulation, IoT, artificial intelligence, and more. And recently, a new digital paradigm like the digital twin has emerged, trying to integrate these technologies towards a service-oriented vision that can allow the manager, so the user of this digital platform, to monitor but also analyze, plan, and change the behavior of the buildings. So we have some gaps and some challenges. Relating to the gaps, for example, we know that developing these systems is still a resource-intensive operation from the technical but also financial point of view, with high expertise required because we need building engineers, architects, IT specialists, and so on, you know, but also with sometimes economic but also cultural benefits difficult to comprehend for the main stakeholders. On the other hand, we have also technical challenges related to the world of data integration with data during the operation of buildings spread among different data silos, but also between different stakeholders, exchange in different languages, and basically causing often interoperability issues. So to address some of these issues, not all, some of these issues, we are advancing the BTwin project, as anticipated you, with the aim of conceptualize the system on the one hand, but also to provide some tools and solutions to, how can I say, facilitate the prototyping of such technologies, and in a vision directed to the market, but also to the research and education in the field. So basically, we are developing a toolkit that I show you in the next slides, that on the one hand tries to use BIM and topological models to produce and run different kind of analysis, for example, energy, occupancy, or comfort analysis, and that on the other hand allow to integrate the data coming from this analysis within graph structures, but not only, and finally to perform data visualization in form of key performance indicators in a user-friendly dashboard. So all these functions are supported by the BTwin toolkit I present here for the first time today. That is basically a Python library that I hope to publish by the end of this year, that facilitates linking data into graph structures again, by using an open source framework and or other open source libraries, Python libraries that are commonly used in our sector to facilitate the integration, the prototyping, and then visualization of relevant data pertaining or related to performance of buildings. And the toolkit is based on some reference Python libraries, but also on the connector logic that we are developing to try to align some relevant data schemas in our industry within our tool to streamline further the prototyping phase of this similar tool. So the final aim is to produce a digital decision support system that is better defined here in this slide with several layers that starts from the data acquisition to the data transmission, then storage, extraction and processing, integration and visualization layer. And the aim of the toolkit is to produce similar prototypes in a basic manner, I'll show you later, with the specific focus of this presentation that pertains to the integration and visualization layers, the last one, but with previous experiences that we conducted also with external collaboration in the data acquisition and extraction and processing layer. So here you can see the simplified version of the methodology I show you today. Basically, we have different data sources, such as, for example, a very simple BIM model of this fictional case study, but also some sensor data that are also fictional, but I want to present the method and not the real application I hope I'll do in the future. Then all these data are formatted according to a JSON LD data format, which is according to a federated ontology that supports the toolkit. Then we have other functions in Python, thanks to this library, that convert this format in knowledge graphs, and then other functions that allow for the extraction of data and visualization in prototype services. Here you can see briefly the ontology. We federated starting from other relevant ontologies in the sector, such as IFC, but also the building topology ontology, the SSN for sensors, but also the brick schema and the energy management KPI ontology. You find more details in the paper. And you can see an example of the data format we choose for representing data in this library, so to prototype this system. Basically, there are two parts, the context part that defines the concept in the JSON LD data, and the graph part when all the objects belonging to the graphs are mapped, with indication about the type of the object, for example, a story, a space, a sensor, a property set, and so on, but also indication about the relationships of different elements as in the linked data approach. So I want to continue briefly with a very simple demonstration of how the toolkit can be used for similar purposes. This is the workflow we presented in the paper, and I'll show you step by step. Basically, here we started with a very simple BIM model of this fictional building. We used Topologic in this case, that is a software produced by the Cardiff University in the UK, just because it allows us to be more faster in the prototyping and developing the tool. Basically, we have 4 simple spaces with basic properties about the geometries of the different spaces, but also on the set points, for example, for the temperature, humidity, and illuminance, set as requirements, as comfort requirements of the different environments. Then we used with other Python function, we use other Python function to align this model with our JSON linked data model. So here you can see the extraction and representation in this format of all the spaces within this case study building. The same for sensors, so we place some fictional sensors within the different buildings and again represent them with another connector into the JSON LD data format. Then integrate this different data in graph structures by using the NetworkX library, always in Python. And in parallel, we store some time series data about the recording of the sensors about, for example, temperature, humidity, and luminance inside the rooms within an SQL database, yes, in this case. And then, again, integrated this data to calculate the KPIs. So, for example, the number of hours with discomfort related to the temperature set point, and but also for the humidity, luminance, and so on. And when you also use in the final step some other functions to develop visualization and developing basic web application thanks to the use of Plotly and Dash libraries. Here you can see a preview of the result. The idea is that you can parse the properties, in this case of the spaces, of other relevant data about the building information model, but also you can interact with the graph for filtering, sorting, I don't know, selecting some objects, investigating the relationship between the objects, and so on. This is in the vision that this platform can be used also to non-expert users of digital decision support system or similar things. So yes, you can filter all these nodes by type, by property, and these things. Then you have the opportunity, okay, just some second, the opportunity to parse, for example, as you want, the time series data here. And finally, to investigate, thanks to some visuals that always are produced thanks to the Python library, here to inspect how the KPIs are distributed along the spaces or in different graphs and so on. So I go to the conclusion by showing you another two videos. Now we are working to scale up this library that actually has been developed but not published yet. And we are moving towards two different integration and development. Of course, we are also analyzing and trying to scale up the solution with more complex buildings, as in this case, but also investigating the interaction with building performance simulation. As you can see on the left, we developed this simple dashboard to investigate how different occupancy scenarios impact the energy needs, of this case study building. Or on the right, how large language models can be used thanks to prompt by users to make structured query for the graphs and extract relevant data from the graphs for non-digital experts that could be interested in the in using this platform. So I ended with my presentation, and I want to thank you for your attention.